We think of ourselves as the pinnacle of creation, but our lives are laughably fragile. A few minutes without air, a slight change in temperature, and we're gone. But what if I told you that some creatures on this planet treat death not as an ending, but as an inconvenience? They've conquered the void of space, reversed aging, and mastered resurrection. And what they can do will make you question everything you think you know about the limits of life itself. The immortal astronaut. The first of these titans is not some marvel of science fiction, but a microscopic animal called the tardigrade that lives in the moss and damp soil of an ordinary backyard. With its pudgy, segmented body and 8 clumsy legs, it's often called a water bear or moss piglet. It is, by all accounts, one of the strangest and most indestructible organisms on our planet. For the Photon M3 mission, the European Space Agency placed colonies of these tiny creatures on the outside of a satellite, offering them no protection whatsoever. For 10 full days, they were exposed directly to the vacuum of space and simultaneously bombarded by levels of unfiltered solar and cosmic radiation, 1,000 times higher than anything that reaches the Earth's surface. When the capsule returned, scientists found something astonishing. Not only had many of the tardigrades survived, but they simply rehydrated and ambled away as if nothing had happened. It was a biological impossibility. Some females even went on to lay healthy eggs, which hatched into perfectly normal offspring. The secret to their survival is a biological superpower that borders on magic. When faced with a lethal environment, the tardigrade enters a state of suspended animation called cryptobiosis. It retracts its legs, curls into a tiny desiccated ball called a ton, and expels over 97% of its water. It then floods its cells with special proteins that form a protective, glass-like matrix, shielding its delicate internal structures from total destruction. In this state, it is virtually immortal. Scientists have cooled them to negative 272 degrees Celsius, just 1 degree above absolute zero. They've been boiled at temperatures over 150 degrees Celsius. They have withstood pressures 6 times greater than those in the deepest part of the ocean, the Mariana Trench, enough to instantly crush a submarine into scrap metal. The water bear is a living testament to nature's resilience, a creature that can effectively pause life itself to cheat death. It proves that life doesn't have to be a one-way street. If a microscopic animal can simply pause death, does that mean our own biology is just lazy? Is mortality a law, or just a habit we haven't learned to break? It can survive the absolute hostility of the void, but other creatures have conquered an even more fundamental barrier here on Earth, the relentless march of time and death itself. The creature that defies death. For every living thing on Earth, the arrow of time flies in one irreversible direction, from birth to growth to an inevitable end. But deep in the ocean, a tiny creature has found a way to defy this fundamental law of nature, armed with the power to grow young again. It is called Turritopsis dohrnii, known to the world as the immortal jellyfish. No bigger than a pinky nail, its translucent body and delicate tentacles drift through the water, hiding one of the greatest secrets in the animal kingdom. Like other jellyfish, it begins life as a free-swimming larva that grows into a stationary stalk called a polyp. This polyp then buds, releasing genetically identical, free-swimming medusas, the classic jellyfish form. For any other species, this final stage is the end of the line. The medusa will grow, reproduce, and eventually die. But for Turritopsis, this is merely a suggestion. When faced with the end of its life, whether from old age, physical injury, or starvation, the immortal jellyfish can initiate a stunning reversal. Its bell begins to fold inward, its tentacles retract, and it sinks to the ocean floor. It is not dying, it is resetting. In a process called transdifferentiation, its specialized adult cells transform back into different cell types, the biological equivalent of a skin cell turning into a heart cell. The entire animal absorbs its own body, melting back into a cyst-like blob, which then develops back into a polyp, restarting its life cycle. It is like a butterfly, upon reaching the end of its days, folding its wings and choosing to become a caterpillar once more. Theoretically, this cycle of regeneration can repeat forever, making the creature biologically immortal. This does not make it indestructible. It can still be eaten or succumb to disease. But it has achieved something no other animal can. It has defeated death by natural causes. This unique ability has allowed it to silently conquer the globe, hitching rides in the ballast water of cargo ships to spread far from its native Caribbean waters. The jellyfish has a biological reset button. It makes you wonder, if we could live forever, cycling through our own lives, would we become gods or just prisoners of time? The immortal jellyfish has conquered the end of life by mastering its beginning. But while it found a way to escape the slow march of time, other creatures survive in places where life should have no beginning at all. Environments of crushing pressure and impossible heat, straight from a vision of the underworld. The worm that breathes fire. 2 miles beneath the ocean's surface, in a realm of absolute darkness and crushing pressure, stand vast mineral chimneys spewing a superheated toxic brew. This is the world of hydrothermal vents, a landscape so hellish it was once thought to be utterly devoid of life. Yet even here, something thrives on the very edge of the inferno. It is the Pompeii worm, a creature that builds its delicate, paper-like tube homes directly onto the sides of these underwater structures known as black smokers. These vents are fissures in the Earth's crust, blasting out a jet of water superheated by magma to temperatures exceeding 400 degrees Celsius. While the worm doesn't live in the direct path of this blast, its home is a place of extreme thermal violence. It is the most heat-tolerant complex animal ever discovered, navigating an unbelievable temperature difference across its own small body. With its tail end anchored deep inside its tube, the worm can endure water temperatures of 80 degrees Celsius or 176 degrees Fahrenheit. Simultaneously, its head, crowned with feathery red gills, peeks out to breathe and feed in the surrounding deep-sea water, which can be a chilly 22 degrees Celsius. Think about that for a second. No other animal is known to survive such a massive and sustained temperature gradient. For years, how it managed this feat was a profound mystery. The answer is that the worm does not endure this alone. Its back is covered in a thick, grey, fleece-like coat of bacteria. This is not an infection. It is a living, breathing fire suit woven from cooperative bacteria. The Pompeii worm cultivates these microbes, feeding them a sugary mucus it secretes. In return, the bacterial fleece acts as a living heat shield and detoxifies the vent's poisonous chemical soup, neutralizing the heavy metals and sulfides that would be lethal to almost any other creature. It has turned a toxic, scalding geyser into a life-giving oasis. It built a paradise in a place that should be pure destruction. It makes you ask, are our own limits real, or just the ones we've never dared to test? The Pompeii worm built its kingdom in a place of fire and pressure, mastering an environment that should instantly destroy flesh and bone. But other invisible forces are even more destructive than heat, silent killers that tear life apart at the genetic level. And a creature exists so resilient it can be found calmly thriving in the radioactive heart of a nuclear reactor. Conan the bacterium. Imagine the aftermath of a nuclear detonation, a landscape sterilized by a flash of unimaginable energy. The very air is charged with radiation, a silent, invisible storm that shreds the blueprint of life, DNA. Yet in this atomic wasteland, something would not only survive, it would begin to thrive. This creature is a bacterium named Deinococcus radiodurans, better known by its nickname Conan the bacterium. It was discovered in the 1950s, not in a reactor or at a bomb test site, but in a simple can of ground meat. Scientists had blasted the can with a dose of gamma radiation they believed would kill all microbes. But when they later opened the supposedly sterile can, they found it swarming with a tiny pink-hued organism that was completely unfazed. To understand its power, consider the lethal dose of radiation for a human is around 500 rads. A cockroach can withstand perhaps 15,000 rads. Conan the bacterium can endure 1.5 million rads without breaking a sweat. That is 3,000 times the dose that would kill a person. This amount of energy literally shatters the creature's own DNA, breaking its circular chromosomes into hundreds of disconnected fragments. For any other form of life, this genetic destruction would be absolute and final. For Deinococcus, it is merely a temporary inconvenience. Within its microscopic cell walls lies the most efficient DNA repair system ever discovered. After its genome is pulverized, specialized proteins and enzymes calmly go to work. They meticulously gather the broken pieces of its DNA, check them against multiple backup copies of the genome stored within the cell. A perfect blueprint, and stitch the strands of the double helix back together in the correct sequence. The entire process, transforming hundreds of broken fragments into a perfect, functional set of chromosomes, can be completed in as little as 12 to 24 hours. As if nothing ever happened, this bacterium treats its own genetic code like a puzzle it can solve over and over. If our own DNA is so fragile, are we the masterpiece of evolution or just a beautiful temporary draft? It is a master of genetic resurrection, a creature that has tamed the atom's destructive force. Surviving a force that tears you apart from the inside out is one thing, but what about surviving a death that comes from the outside in? A creeping, absolute cold that stops your heart, freezes your blood, and turns you into a solid block of ice. The frozen zombie. Deep in the northern forests, as winter tightens its grip, a small creature settles into the frozen earth. Ice crystals form in its skin, its blood, and its organs. Its heart flutters and then stops. By every medical definition, it is dead. The creature is the common wood frog. While other amphibians burrow deep below the frost line, the wood frog has a far more radical strategy. It hibernates in shallow hollows directly in the path of the killing frost. It does not evade winter, it embraces it. As the first ice crystals touch its skin, a panic signal is sent throughout its body, not to flee, but to prepare for an act of biochemical magic. The frog's liver begins working overtime, converting vast stores of glycogen into glucose and flooding its circulatory system with the sugar. This thick, sugary syrup acts as a natural cryoprotectant, or antifreeze. It cannot stop the frog from freezing, but it controls how it freezes. The water between the frog's cells is allowed to turn to solid ice, but the syrupy fluid inside the cells is protected, remaining a viscous liquid. This prevents the formation of ice crystals within the cells themselves, which would shred them like tiny daggers. For weeks, sometimes months, the frog is a solid block of ice. Up to 70% of the water in its body is frozen. Its heart is silent. Its brain shows no activity. Its lungs are still. It is a lifeless statue. But when the first warmth of spring touches the forest floor, the miracle begins in reverse. As the world thaws, so does the frog, from the inside out. The syrupy heart is one of the first organs to defrost. A flicker of electrical activity returns. It contracts once, then again. Slowly, miraculously, it sputters back into a steady rhythm, pumping the cryoprotectant-rich blood through its frozen veins. Within a few hours, the lifeless popsicle is hopping away, perfectly healthy. The frog proves the line between life and death can be blurred and crossed. It forces us to wonder if death is a final destination or just a state of being we haven't figured out how to reverse yet. The wood frog has mastered the boundary between life and death, turning its body into a vessel that can withstand the stillness of the grave. But freezing is a temporary death with the promise of a spring thaw. One of a creature that faces a different kind of stillness, a slow, creeping death by thirst, with no guarantee that the life-giving rains will ever return. The fish that forgot water. Imagine a sun-scorched African landscape, where the earth has cracked into a parched mosaic and the riverbeds are nothing but dust. This is a world defined by the absence of water, the last place on earth you would expect to find a fish. But buried deep beneath the baked clay, one is patiently waiting for the rain. This creature is the West African lungfish, an evolutionary marvel that has solved the ultimate problem for an aquatic animal: how to survive when the water disappears. During the wet season, it lives as any other fish. But unlike other fish, it possesses a secret weapon, a primitive lung that allows it to breathe air. When the dry season arrives, this lung becomes its key to survival. As its world evaporates, the lungfish is spurred into action. It begins to dig, using its mouth to chew through the soft mud of the riverbed, carving a vertical tunnel deep into the earth. Once at a safe depth, it stops and prepares for its long sleep. It secretes a copious amount of mucus from its skin, which mixes with the surrounding mud. This mixture dries into a thin, tough, waterproof cocoon that encases its entire body, leaving only a tiny tube connecting its mouth to the surface for air. Sealed within this protective chamber, its body enters a state of extreme suspended animation called estivation. Its metabolism slows to a crawl, dropping to just 1/60th of its normal rate. Its heart rate becomes almost imperceptible. It ceases to produce waste, instead converting it into urea, which it stores in its tissues. In this death-like stasis, the lungfish slowly consumes its own muscle tissue for energy, waiting. It can survive like this for an astonishing length of time, sometimes for 3 to 5 years. Then, when the rains finally return, the water seeps down, softening the hardened cocoon. The fish awakens. Its metabolism roars back to life. It breaks free from its tomb and wriggles back to the surface, returning to a world reborn with water. It survives by having absolute faith that its world will return. How many of us could simply shut down and wait for years to be saved? And what does that say about our own definition of hope? The lungfish is a master of patience, a creature that survives the death of its world by entombing itself in the earth. But what about a place where there is no world to wait for? A desolate summit at the top of the world, a death zone where survival isn't about waiting, but enduring a permanently hostile environment. The mountaineer of Everest. High on the slopes of Mount Everest, above 26,000 feet, mountaineers enter a region known as the death zone. Here, the air is so thin that the human body begins to shut down, starving for oxygen with every breath. But this lethal, frozen landscape is the hunting ground for one of the highest permanent residents on Earth. It is a tiny creature, no bigger than a thumbnail, a minuscule predator in a world of giants, the Himalayan jumping spider. Its scientific name, Euophrys omnisuperstes, is a perfect summary of its existence. It means standing above all. This is not an exaggeration. This spider makes its home in the barren, wind-swept crevices of the mountain, enduring conditions that defy the limits of biology. The air pressure is a third of what it is at sea level. The temperatures rarely climb above freezing and plummet at night to brutally cold lows. The atmosphere offers little protection from the sun's intense ultraviolet radiation. There is no vegetation, no soil, nothing we would typically associate with a living ecosystem. So how does it survive? It breathes through a highly efficient respiratory system. Special chemical compounds in its blood act as a biological antifreeze, protecting its cells from being ruptured by ice crystals. But the real secret to its survival is its diet. It is a scavenger at the top of the world. It survives on a grim, frozen buffet delivered by the wind. Powerful updrafts from the lower valleys sweep smaller, unlucky insects, gnats, flies, and other arthropods high up the mountainside, where they are flash frozen and deposited on the rock and ice. Using its 8 keen eyes, Euophrys omnisuperstes stalks this frozen landscape, hunting not for living prey, but for these tiny, accidental mummies. It is the ultimate opportunist, surviving at the edge of the world on the misfortune of others. It is a tiny speck of life in a vast, vertical desert, a creature that has conquered the most formidable mountain on the planet, not through size or strength, but through quiet, relentless endurance. It lives in a place defined by what it lacks: air, warmth, food. It proves that life doesn't need abundance to thrive, just an opportunity. Are we truly limited by our environment, or just by our imagination? The Himalayan jumping spider makes its home in a place of endings, a desolate summit where life is not meant to exist. But this spider survives by consuming what is dead. There is another microscopic creature that takes survival a step further. It endures by stealing the very essence of what is living, ripping out pieces of its victim's DNA to make itself stronger. The time-traveling thief. What if a creature could completely dry out, crumbling into a lifeless speck of dust, and then, with a single drop of water, spring back to life? This is not a scene from science fiction. It is the bizarre, seemingly impossible reality for a microscopic animal that has cheated death for millions of years. The creature is the Beedeloid rotifer, a tiny, wheeled animal, common in transient puddles and damp mosses. Its home is, by its very nature, temporary. When the water inevitably evaporates, the rotifer does not die. It performs an act of self-preservation called anhydrobiosis. It shrivels into a microscopic husk, its metabolism dropping to an undetectable level. In this state, it can survive almost anything. In 2021, scientists in Siberia successfully revived a rotifer that had been frozen in the permafrost for 24,000 years. The process of total dehydration is incredibly violent on a cellular level, shattering the creature's DNA. To survive this, the rotifer evolved an unparalleled ability to repair its own genetic code, which also made it incredibly resistant to radiation. But its method of repair is where the story turns from the incredible to the truly alien. It is a genetic thief. When the rotifer rehydrates, its cell membranes become temporarily permeable. As it absorbs water, it also absorbs fragments of DNA from whatever was around it in the dust, the remains of bacteria, fungi, and algae. It then uses this stolen genetic material as a patch kit. Its cellular machinery takes these foreign genes and uses them to help piece its own shattered chromosomes back together. Up to 10% of the Bedaloid rotifer's active genome is believed to have been stolen from other kingdoms of life. For over 50 million years, these creatures have existed as an all-female species, reproducing only by cloning themselves. They abandon traditional reproduction and, instead, turn to theft to keep their genome fresh and resilient. It rebuilds itself with the DNA of others, becoming a mosaic of everything it has consumed. It poses a disturbing question. At what point does a survivor, pieced together from spare parts, cease to be itself? The Bedaloid rotifer is a master of survival, a biological pirate that endures the end of its world by literally stealing the building blocks of others. But this creature rebuilds itself after the danger has passed. What of life that must exist perpetually within the danger, making its home in a toxic soup so corrosive it can dissolve solid metal? The demon of the acid pools. There are places on Earth that look like a vision of another world, volcanic springs that bubble with sulfur and steam with heat. The water here is not water at all, but a simmering bath of sulfuric acid, strong enough to dissolve metal and instantly destroy living tissue. And yet, in this toxic soup, something is thriving. This is the realm of the acidophiles, or acid lovers, microorganisms that have mastered life in the planet's most corrosive environments. One of its most extreme members is an archaeon named Picrophilus torridus. It makes its home in Solfatara's volcanic vents, where hot gases mix with groundwater to create pools of near-boiling acid. It is one of the most extreme acid-loving organisms ever discovered, flourishing at a pH of 0.7. For context, neutral water has a pH of 7. This is 10 million times more acidic, a level comparable to the acid in a car battery, and it prefers this environment to be a scalding 60 degrees Celsius or 140 degrees Fahrenheit. For any normal cell, this world would mean instant dissolution. A high concentration of acid would tear through the cell membrane, unravel its proteins, and shred its DNA in seconds. But Picrophilus torridus has evolved a unique defense. Its cellular membrane is constructed of a special lipid monolayer, a molecular shield incredibly resistant to being breached by acid. It is essentially wearing a suit of biological acid-proof armor. But this adaptation is so complete, it has created a profound paradox. The very thing that would kill us is the only thing that keeps it alive. The structural integrity of its special membrane is entirely dependent on the extreme acidity of its environment. If you were to place this creature in a neutral pH solution like pure water, its cellular shield would fail, its membrane would lose cohesion, and the organism would simply fall apart. Its poison is its paradise. It's a chilling reminder that our reality, our definition of what is safe and what is deadly, is just one opinion in a world full of extremes. The acidophile has embraced the very definition of corrosion, building its existence within a liquid designed to unmake all others. But what about the survivors of a more familiar kind of apocalypse? The creatures of legend, the ones we joke, will be the sole inheritors of a world we leave behind. The myth and the survivor. There is an old, dark joke about the end of the world. It says that after the final bombs have fallen and the dust of civilization has settled, only one creature will be left to inherit the earth. This is the story of that legendary survivor, the cockroach. Its reputation for indestructibility is woven into our modern folklore, built primarily on its supposed immunity to nuclear radiation. The truth, however, is both less and more impressive. While a human can withstand a dose of around 500 rads, the common cockroach can endure up to 15,000 rads. This is certainly lethal to us, but it pales in comparison to the true champions of radiation resistance. Its resilience is not a superpower, but a simple accident of biology. Its cells divide much more slowly than ours, roughly once a week. Since radiation is most destructive to rapidly dividing cells, the cockroach simply presents a slower-moving target. No, its true genius for survival is far more intimate. Forget radiation, this is where the true horror lies. You can, for instance, cut off its head and it will not die. It lacks a high-pressure circulatory system, so it will not bleed out. It breathes not through its mouth, but through tiny pores called spiracles in its body segments. Its decentralized nervous system allows its body to continue reacting to stimuli for weeks, a headless automaton that only finally succumbs to thirst. It can survive being submerged in water for over 30 minutes by shutting down its respiratory system completely. It can go for a month without a single meal, and its famously indiscriminate diet means that almost anything can become food. The glue on a postage stamp, a scrap of paper, a bar of soap. But its greatest survival skill is not found in a single grotesque trick. It is written across 300 million years of Earth's history. The cockroach blueprint is ancient. These creatures crawled beneath the feet of dinosaurs and skittered through the ferns of the Carboniferous period. They survived the asteroid that wiped the great lizards from the planet. They have endured ice ages, volcanic cataclysms, and multiple mass extinctions, all while remaining fundamentally unchanged. Its genius is its simplicity. It is a master of not dying, a minimalist survivor that has outlasted empires, epochs, and countless more complex creatures. We began by talking about our own fragility. After seeing these creatures, it's clear that survival isn't about strength, but about invention. They are a reminder that the rulebook of life can be rewritten. The question these immortal, indestructible, impossible survivors leave us with is not how they do it, but why we don't.